Hello all, welcome back. In this video, we'll be discussing about red black tree deletion. In the previous video, we discussed what is red black tree, what are the properties of red black tree, and how insertion happens in red black tree. So if you didn't check the video, please go back and check that. Now coming to red black tree deletion. So what are all the steps we need to follow when we are performing deletion in red black tree? And here are some steps I have given. First, we need to follow binary search tree deletion. Okay, basically how do we do deletion in a binary search tree? So we have three cases in that. That is, if the node that we want to delete is a leaf node, then we can directly remove that leaf node from the tree. Okay, no need to perform any operation again. And what if the node that we are going to delete is a non-leaf node, or we can say it is an internal node which is having only one child? So in that case, we'll be replacing the node with the child node. Okay, and then we will be deleting that particular node. This is what the second case. Now coming to the third case, what if the node you want to delete is having two children? Okay, so what you need to do, first find the in-order traversal of the tree. Okay, after finding the in-order traversal, choose either in-order predecessor or in-order successor. Okay, so replace the node you want to delete with this in-order predecessor or in-order successor that you found. Okay, then after replacing it, you can directly remove that node from the tree. Okay, this is what the deletion operation generally will do when it is a binary search tree. The same thing we are doing here in red black tree as well, but along with few more steps. What is that step is, we already have seen some of the properties of red black tree. So when we are performing deletion, in some cases, in some deletion operation, it may violate those red black tree properties. So every time we need to make sure whether it is not violating the property. Okay, so that is what the additional check we need to perform when you are doing deletion in red black tree. Okay, so after deletion, what we have to do, we need to make sure the properties of red black tree, whether any property is violated or not. And mostly in case of deletion, when we are performing deletion of black node, at that time it will violate the property. Okay, mostly this is what happen in deletion. When we are performing insertion, we'll be concentrating on the consecutive red nodes. At the same, like in the same way, when we are performing deletion, we need to check for the number of black nodes. Okay, when we are performing a deletion in the black node, we need to check for the number of black nodes in each and every path. So that is what we have to concentrate when we are performing deletion. Now we will see how to perform deletion, and what if we perform deleting a red node or a black node, what all the changes will happen, how the property gets violated, and how we can balance the tree. Okay, in what ways we can balance the tree, that all we will discuss now. Here, for deleting a node in a red black tree, I am considering two cases. The first case is deleting a red node, and the second case, deleting a black node. Okay, these two are the major cases that I am considering here. Again, for these two major cases, we have sub cases as well that we will discuss. Okay, now my first case is deleting a red node. See, when you are deleting a red node from the red black tree, we will not get any property violation. Okay, maximum we will not get any violations of properties when we are deleting a red node from the tree, and that red node can be a leaf node or non-leaf node, whatever, but we don't get any violation of the properties. That we will see now. See, when I want to delete a red node and that red node is a leaf node, that is what my case 1.1. So I'm deleting a leaf node which is a red node. Here this is an example where I have the node 3, it is a red node, and this is the leaf node. If I want to delete a leaf node, what I can do, I can directly delete that leaf node from the tree. Right, this is what the binary search tree deletion, I can directly delete it. But here also you need to check for the color. So which color node I am deleting, whether I am deleting red node or black node. If the node I am deleting is a red node, then you can directly delete, because it will not violate the black color property, that is number of black nodes in a path property will not get violated. So after deleting 3, this will be my resultant tree. Okay, if you check here, how many number of black nodes are there? In this path 2 black nodes, and in this path 2 black nodes. So there is no property violation, and this is the case when I'm deleting a leaf node. What if I delete a non-leaf node, or you can say internal node? So here also you need to check, when you're deleting an internal node, how many children the node has, one child or two children. If it is one child, directly swap the child and parent and delete it. If it has two children, take in order and then find the predecessor or successor, then swap those and then delete the node from the tree, right? And here in this case you can see, I have this tree. In this tree I want to delete value 4, okay, which is red in color, and this is an internal node because it has one child. So if I want to delete this node having one child, first what I need to do, I need to replace this child node with the parent node value. Okay, so after replacing it, I can directly delete this 4 from the tree. Okay, and since I'm deleting red node, okay, what I'm having here, I'm having one more node here which is black in color. It can be red or black, whatever. So what I'm doing, I'm directly swapping this with this node to be deleted, okay, red node. But when you are swapping, I'm not going to change the color of this node, okay. This color node color should be retained as it is, because you are just deleting the red node, delete it directly, and this node color should be retained as it is, okay. So this is what after deleting a red node which is not a leaf node. These two are the cases that comes under first case, that is deleting a red node. And what is the second case? Deleting a black node. What if the node that I want to delete is a black node? So under that again we have sub cases. So if you are deleting a black node, again you need to check whether you are deleting a leaf node or you are deleting a non-leaf node, okay. If the node to be deleted is a leaf node, again we have sub cases. Again it is like subdivided into many cases. So that I'll discuss later. Before that, first we will check what if we delete a non-leaf node that is black in color. Okay, deleting a black node which is a non-leaf node or internal node. We'll check that property first. So in case 2, when you are trying to delete a non-leaf black node, okay, and that is containing red child, okay, then what we need to do for that when we are getting any unbalancing, okay, when the tree is unbalanced, what we need to do, how to balance the tree. You can see here I want to delete the node value 6, okay. Here is an example. A node is 6 that is black in color, which is a non-leaf node, because you can see it has one child node. And what is the color of its child? It is red color. If it has red child, what if a node, non-leaf node, black node that I need to delete having red child, then how do I perform deletion? In this case, swap the node value with its child, okay. After doing swapping, you can directly delete the node. But when you are performing swapping operation, here in this case you need to retain the color of this parent node, okay. Don't change the color of the parent node. In the previous case, what we did when we are performing deletion of red node, at that time we should not change the color of child node. We should retain the color of child node as it is. But here when you are performing deletion on black node, you should retain the color of this parent node, black node. You shouldn't change the color of this parent node. Instead you are changing the color of this child node. So after deleting 6, what happened? 7 becomes the node here, okay. 7 gets placed here, and check the color of this 7. It is black in color, okay. So the parent node color is retained as it is not changed, okay. This is what deleting a black node, that is non-leaf black node with red child, okay. And now coming to the previous case, that is when I want to delete a node, black node, which can be a leaf node or which is a non-leaf node with black child. What is that case? Okay, that we will check now. So this is the next case. I'm deleting a black node, and what if that black node is a leaf node? Okay, leaf node means which doesn't have any child node. So here is an example, and in this example I want to delete 20. Okay, if I delete 20, then this will be my tree. Since this is leaf node, directly I can delete this. Okay, so after deleting it, the tree contains 30, 40, 35 and 50 as it is. But this node gets deleted. So once you are deleting a black node from a tree, then this will be replaced with null value, because I deleted this, so nothing will be here, so it is replaced with null. But you check the color of this node and the circle is, it is double black. Okay, this case is called as double black. Okay, whenever you are deleting a black node which is a leaf node, okay, which doesn't have any child node, after deleting you need to make it as double black. Okay, so this is how you have to perform deletion of black node in a red black tree. Okay, so once you change it as double black, now in this part the count of black will be 3, because here it is 1 and here 2 black, right? So totally 3. But in this path, if you check how many black nodes are there, only we have 2 black nodes. So this is not balanced. We need to balance this. So this condition is unbalanced. Okay, so when you have any double black, at that time we can say blindly that the tree is unbalanced. We need to eliminate this double black in order to balance the tree. So how do we eliminate this double black? Right, so this is also dependent on the sibling of this node. Okay, whatever the node you have deleted, based on the color of the sibling, okay, we are going to eliminate this double black. Right, in this we have subdivisions again, sub cases. So I'll tell one by one. Now take this node, that is null node, check with the sibling of this node. So what is the color of the sibling? If the color of the sibling is black color, okay, again check with the child of that sibling, okay, whether this black contains any child that is red in color. At least one child is red in color. Okay, in that case we need to perform rotation. So after performing rotation, this double black node will get eliminated. right? Understood? So what you are checking after getting double black, you need to check with the sibling of that node. So what is the color of the sibling? Black color. If it is black color, then check the child of that black node. If any one child is red in color, then perform rotation. So you can see in this case we have two red nodes, so you can choose any one child and perform rotation on it. So this is our tree. After deletion we got this. So double black, null. Check the sibling is black in color, and this black sibling has two red child. So what I'm doing, I'm choosing this red child and I'm performing rotation. Where do I perform rotation? I can perform rotation on these three values, these three nodes. So if you look at the structure of this tree, this is right skewed. If it is right skewed, how do I perform rotation? I can apply single left rotation, LL rotation. So if you apply LL rotation, single left rotation, then 40 will become the root node, 30 will come as the left child of 40, and 50 will be the right child of 50. Okay, and now 35 you need to place. 35 is in left of 40. So start comparing from 40. Left side you need to place 35. Again compare 35 with 30. 35 is greater than 30. So place it in the right of 30. Okay, this is what we done now. And if you look at the color, okay, what are all the color changes happen here? You are changing only one color, that is the child node color, from red to black. In this way, you are eliminating this double black. Okay, by changing the color of the child node from red to black, which means you are passing one black color here. Okay, so you have changed the color of this node. In this way, this double black gets eliminated from the tree. Okay, since one black gets eliminated, we'll have only one black with null, which means there is no node here. So it is not necessary to mention the node here. Okay, that is why I didn't mention null anywhere in this tree, in the resultant tree, because it's already null with only one black. So we always consider when there is no node, that is null node, and by default it is in black color. So I'm not mentioning that null after doing this operation. Now your tree is balanced. You can check how many number of black nodes in this path, how many number of black nodes in this path. So it is equal. Now the tree is balanced. So when you are doing this, when you get double black node after performing deletion, if you get double black, and to eliminate that double black we are doing this, and when we are doing this operation, rotation and all those things, when the sibling is black in color and at least one child of the sibling is red in color, okay, in this case you are performing this rotation and recoloring. And the next case, okay, we checked first case, and in the next case again the sibling is black color. Okay, the sibling is black in color, there is no change in that. But what if the sibling doesn't have red child, it is having only black child or no child? No child is also means that what, it is black, null black. So what if the sibling, black sibling, is again having only black nodes, there is no red node at all? At that time what we need to do? We need to perform recoloring. Okay, if it has red child, if the sibling is having red child, perform rotation. If if the sibling has only black children, okay, then what you do? Perform recoloring. And what you are recoloring? You are recoloring on sibling and the parent node. Okay, you are recoloring on sibling as well as what? Parent node. Now coming to parent node. What if the parent is already black in color? If the parent is red in color, you can recolor it to black, from red to black. But what if the parent is already in black? Okay, then in that point you need to mark that parent, black parent, as double black. Okay, this point you need to keep in mind. When the parent is already black in color, then mark that as double black. Mark the parent as double black. Now, if the parent is root node, okay, if the parent is root node and it is double black, then you can directly eliminate that double black color without performing any operation, any rotation or recoloring. Directly you can ignore that double black once the parent is root node. Okay, if it is not root node, again you need to follow the same procedure, same process. Again compare it with the sibling, what is the color of the sibling and what is the color of its sibling child. Based on that, again you need to do some operations. Okay, but if in case it is a root node, parent is a root node and the parent node is double black, then you can directly eliminate it and you can consider it as a single black. Okay, so we'll see one example for that. Now this is the tree, and in this tree I want to delete 10. So if I delete 10 in this place, what will happen? It will become null value with double black. So once a double black exists in a tree, you need to eliminate that double black. How do you eliminate? By checking its sibling color. What is the color of sibling? Black color. But what is the color of its sibling's child? There is no child at all. If there is no child, what you will do? It is considered as black color. If this black sibling is having black child or no child, what you need to do? You need to perform recoloring. And where you are recoloring? Recoloring on the sibling and parent. So here for this node, what is a sibling? 30. So recolor it from black to red. And what is a parent? 20. Recolor 20. But if you see 20 is already in black. If 20 already in black, then you need to make it as double black. Okay, so this black is made as double black now. Now this is the root node, this is this condition, okay, this property. If the parent is root node, and it is double black, then you can mark directly it as a single black because this is a root node. So now after doing that, this will be your result entry. So now it is double black, now this is converted into a single black directly without performing any operation. So 20, right side 30, and left side is null node. Since it is null node, I ignored it here. Okay, both, because writing this and not writing this both means the same. Okay, there is no much difference in writing this, so I just ignored this null value here. Okay, this is what black sibling with black node or no child node. So till now we discussed two cases for black deletion, okay, and those two cases are for black sibling. Okay, if the node you deleted has black color sibling and based on the child color you are performing either rotation or recoloring. Now what if the node you deleted that is having two black is having red sibling? Okay, that is this case, third case. So if it is red sibling, then what we need to do, we need to perform rotation with recoloring. Okay, here is an example you can see. So here what you are deleting, you are deleting the node value 10. If you delete node value 10 and this place, it will become double black null. Okay, if it is double black null, you need to eliminate this. How do you eliminate this? Check the color of the sibling. What is the color of sibling now? It is red color. If the sibling is red in color, what you need to do? Perform rotation with recoloring. So what rotation you can perform? Since this is null, okay, since this is null, don't consider this. Only you're going to take these values. Okay, only you're going to consider these three nodes. If you perform rotation, so the tree structure is right skewed. So perform single left rotation. If you perform single rotation, left rotation, 30 will become the root node, 20 becomes the left of 30, 36 becomes the right of 30. Now come again, take 22. Where 22 will get placed? First compare it from 30, left side 22. So from 30, left side. Again compare it with 20, right side 22. So place it at the right side. Okay, and this null remains as it is as the left of 20. And one more thing, after performing rotation, what you're doing, you are doing recoloring. So where you are recoloring, as it is, you need to recolor parent and the grandparent. Okay, so you're just swapping the color of parent and grandparent, right? So after performing rotation also, this will not get ignored. Okay, this double black will remain as it is. It will not get removed, sorry, it will not get eliminated after performing rotation with recoloring when your sibling is red in color, right? In that case, what you need to do, again check the color of the sibling. Okay, this is the null value, null node. So black node, check the color of the sibling. If the sibling is black in color, again go back to the previous cases. So what if the sibling is black in color? You need to check the child node of that sibling. If the child node is red in color, perform rotation. If there is no child node or the child nodes are black in color, then you need to perform recoloring. Where you are applying recoloring? Recoloring on the parent as well as the sibling. So this 20 will get recolored and this 22 also will get recolored. Once you recolor this will become a single black. So that's what happening here. Still double black exists. So if double black exists, check for its sibling. So check for the sibling. What is the sibling color? It is black color. 22 is a sibling and it's black in color. What is the child node of the sibling? No child at all. So if no child, we are performing recoloring. Recoloring on 20. So 20 red color becomes black color and 22 black becomes red color. You can see this double black becomes single black. So now this gets ignored. This is my final tree after performing the operation, and now the tree is also balanced. Okay, so these are all the cases for red black tree deletion. Basically two cases. One is deleting a red node, the second one is deleting a black node. Again, when you are deleting a black node, at that point after deletion, that place will contain what? Two black nodes. Okay, that is double black. That node will become double black. So whenever double black exists in a tree, you need to eliminate that double black. So for eliminating the double black, you are checking with the sibling color. Sibling black, again sibling black with red child or sibling black with black child. And one more case, red sibling. Okay, if it is red sibling, what you are performing, what you are doing, right? So these are all the deletion. Now I will tell you one more example for this. Here is an example for deletion. This is a given tree. In this tree, we have black nodes and red nodes. So this tree is initially balanced. Now you are trying to delete value 9 from this tree. Okay. So what if you delete 9 from this tree? You just take the color of the value first. So the node color is black color. If you are deleting a leaf node that is black in color, you can directly delete. But still after deleting this, what you need to do? You need to consider a double black node here. So after deleting 9, this becomes what? Double black null. So once a double black null comes into tree, what you need to do? Check the sibling of it. Okay, what is the sibling? That is 7. And what is the color of sibling's child? There is no child for the sibling, which means black color. What if the sibling has black color child node? You need to perform Recoloring on what? Recoloring on the parent node and the sibling node. So this 8 will become black color and the 7 becomes red color, and this double black will become single black. So after performing recoloring, what will happen? 8 becomes black, 7 becomes red, and this becomes single. Okay, so in the result entry, again you are trying to delete the value 8. So where is 8? Here is 8. And is this leaf node? No, it is an internal node. So if you try to delete 8, how many children are there for the 8? There is only one child, which is 7. Okay, so if you are deleting this 8, right, which is a black node, that is internal node, which is having red child. Okay, if it has a red child, what you will do? Directly replace the child with this node and don't change the color of this black node. Okay, retain the color as it is. So that is what this result entry. You can see 7 becomes the node value here, and the color of 7 is black in color. So this black node retains as it is. Right, this is for deleting 8. And in this result entry, again you are trying to delete 7. What if you delete 7? 7 is a leaf node which is black in color. So if I delete this node, so again I'll get double black null. Okay, so this is my tree after deleting 7, double black null. And once you get double black null, we need to eliminate it. How do we eliminate? First check the sibling color. Sibling is black in color. If it is black in color, check the child node. At least one child should have what? Red node or not. If it has red node, then perform rotation. Here 2 children are in red color. So you can choose any one child node and then perform rotation. If you choose this, you can apply single left rotation on this. If you apply single rotation, left rotation, 4 will become the root node, 6 becomes the right child, 2 becomes the left child, and what about 5? 5 is at the right of 4. So to the right of 4, already 6. So check with 6. 5 is less than 6. So place it in the left of 6. Okay, now coming to the color, I told you already. So when you are doing rotation here, you are changing the color, because in order to eliminate this double black, this 2 will get the color of this double black. So this double black color is passed to this red 2, that is red node, and this red will become black. Right, so only this color gets changed from red to black. Because of this double black gets eliminated. Okay, so this is what deletion operation in red black tree.